If we are not the owner of this product instance, we still are able to access our private properties. In Angular, we mostly use the data structures, not the objects. And I will explain you what is the difference. Having the code like this gives you the possibility to test it without the real implementation. And wherever something is changed in this product, you will need to update your calculate sell price function. My name is Przemek, and today I will be talking about the backend knowledge that you can use on the front-end applications as well. On my presentation, I will be showing you some real code examples with followed by tests, unit tests. So you can see the QR code as well as the URL to the repository. If you want, you can browse and follow me during my presentation. And we'll be showing you the whole refactoring process of the object-oriented code. And I will show you how you can use this knowledge to work with the data structures, because in the Angular, we mostly work with the data structures. There is a little bit of object-oriented code, but mostly we work with the data, not the behavior. Okay, and the rules I will be explaining and introducing to you is a rule information expert, dependency inversion, and interface segregation. And at the end of the presentation, I will be showing you what architectural drivers lead me to those solutions. So yeah, let's start from the example, because we'll learn how to do it in practice. So on this screen, we see the simple behavior of the application. On the left, we can see the customer that has some money. He has like $10, and he wants to buy simple product, which is Apple in this case. And the Apple costs $10. So in our application that we will be building, we will be just paying for the Apple, so the money is gone already. And you see the customer has the one Apple. So the first rule that I would like to show you in the practice is this information expert rule. And the rule says basically that responsibility of the class should be responsibility to the class that has the information necessary to fulfill the responsibility. Assign responsibility to the class that has the information necessary to fulfill the responsibility. So basically, that means that you have to move your app behavior to the classes that has the data needed to operate to achieve some kind of goal. So in the first exercise, I will be showing you the two simple classes that represents the example that I shown you before. And the first class is customer. This customer can have some products. It has the name, the money, and the product itself that has SKU, which is like the product identifier. We have the name of the product and the price of the product. And in not very good code, we can see that all of our logic is moved to the application. So this method, this function by product contains a lot of logic that probably should be moved to the object itself. So we see that we need to know about the customer money, we need to know about customer products, we need to know about customer money again, just to subtract it from this object. And what we can do about it, very simple thing, we can move all this customer logic code to the customer object. So we can create the buy product in the customer. And now we see that we don't need expose anymore the money and the products. But still we see one problem, that the So this is the provided solution. So on this example, we see that the byProduct method that looked before like this, when you see the red cross, is changed to very simple, nice function, which use only one method on the customer. But there is one more problem here, because as you see, we use the price from the product. So this is not encapsulated yet. We expose the price from the product, and I will show you how we can deal with it. So the solution for that may be that you can create another method, sell to customer, and then when you pass the customer object to this method, you can see that you can run the customer byProduct and then pass this private property as an input parameter to the method byProduct of the customer. And by this way, you see that we really encapsulated that property, and our customer method is not aware about the product private property anymore, but it's still aware about the price. So we can use it. So our code, our application will look a little bit different. Now, instead of firing the byProduct on a customer, we switch to firing the sell to customer on the product. And by this time, as we are not exposing any properties from the product, we can make all those properties private. I will not do it now, because I want to show you more examples. So let's make a little bit more complex example. So let's add shop to our application. So currently, the customer will be able to buy the products in the shop. So the shop can sell the items to the customer. And the behavior behind this will be that the customer pay the money. So we subtract the money, we got an apple, and the shop has plus $10, but it has one less apple. Let's introduce the shop object here. And now we can create a method, which is called sell to customer. And in this method, we use SKU as an input and customer. And on the first line, you see that we are searching the first line of this method, of course. We see that we are searching the right product with this SKU in the stock of the shop. So again, we see there is one more problem again. We see that we need again the private property of the product, and we want to encapsulate that. I will show you how to do it. So let me explain the rest of the logic. So when we have this product in the shop, we can buy it, but if we don't have it, we just throw an error that the product is not available. So how can we deal with this property that should be private? Because this example is a little bit different. Because currently we see that we are working on an array of the products. It's not a single product. So how can we hide the private property in collections? So I would suggest to do the static method. It's a little nice trick that I use. and we can introduce a method like find by SKU in the product class, which is static. And we see that we can pass the SKU as an input parameter, the list of the products, and we return product or null if the product is not, has not been found. And in this example, you see that even if we are not the owner of this product instance, we still are able to access our private properties like SKU. And by this way, this way allows you to encapsulate very nice methods inside your object. So every time you use your product, you know that you have like handy methods inside your product class, and you can use it. So it reduces a lot code duplication and simplify the development because as you see in this example, the code is much more readable. So instead of running the find method on the stock, we can use just the static method of the product, and it's really nice. And on the bottom, you see removing by SKU looks pretty similar, and it's really nice. But as I said at the beginning, in Angular, we mostly use the data structures, not the objects. And I will explain you what is the difference between two of them. And on the left, you see the object, because instead of having the information about the data shape, the data structure, you have the behavior of the object. And on the right, we see the data structure. And there is, in TypeScript, there is no definition of the data structure. So you can express data structure by using the interfaces or classes. So even if you create the class with public properties, it will not be an object because it does the reason of having that class is not keeping the behavior inside, but only the data. So you can use them like equally and tell that these are the data structures. And how we can encapsulate those nice methods that I showed you before that were static in the class, but using the interface. And I would say that it's a good approach when you keep all your classes related to that object very close together. So, for example, if we see this product interface, which is just a data structure, you can create very close, even in this file, or if you want to move it to the next file, please make sure that those methods or the functions will be very close together to this object. So every time you want to use the product interface, you'll be in reach of those functions. So you can see that those functions doesn't have any other dependencies. They are dependent only on the product interface, which is really easy to recognize where to put those functions. So I've seen in many projects that there are a lot of duplication when we want to, for example, convert some array of some type to the record. You can easily create those kind of functions there, like summing the prices, removing or adding the items to the arrays, because sometimes maybe you will need to add something at the beginning of the array, sometimes at the end of the array, and the possibilities that you can do it here are almost endless. And the first thing I saw in Angular that the amount of the duplication of those kind of things is very huge. And another thing which is bad is that sometimes you want to change this interface. For example, you want to split the price for the net and value-added tax and other things. And you have to walk through all the usage of those functions in the system and change it there. So it's very hard to understand how the change of the interface will affect your application. When you have everything close together and you follow the coupling that the methods has and you keep them very close, it's almost like changing only one file, which is really nice. So at the bottom, you can see that we can group all those functions together, for example, in product utils, and then use them in your application. But let's go further, and we can add some more complexity to our example now. And on the left, for example, we see some kind of supplier because we need to produce our products, and maybe we can sell them to the shop the same way that we've been selling apples to the customer. And let's see how we can do it. So this is the behavior. When shop buys the apples, shop just pay $10 and gets an apple. I didn't want to introduce more and more complexity, so the supplier will just create the objects for the shop and will not. We don't need to track the supplier's money for this example. And as you see, we can do it this way. So we can add another method to our product class, which is sell to shop, because now we have the different object that we want to sell our products to. So we just create another method. But maybe we have a better solution to that. And I will show this solution here. We can use the abstraction. So for example, in this product class, we see that all those methods here are very similar. They do almost the same thing. They have almost the same shape, but the only difference that they have is an input parameter of different type. So how can we unify that and exchange the two methods to single one? For example, we can introduce this buyer interface, which has the buy product method. And in this, we can implement this interface to our shop and our customer object. And here, you can see on the right that even if they have the same method, the behavior of those methods may be different. So for example, in our shop, we don't care if shop has money. Maybe shop can borrow the money from the bank, so it can have debt. But we want to be sure that our customer can only pay by cash. So if customer does not have enough money to buy the product, we do not let him do it. Yeah, so as you see, the product class is very simplified. So now you can see the usage of this product class, that instead of having two methods, now we can have one method and use two objects there. And this will be valid. And what we achieved here that can be used in the Angular, you can see how the dependency inversion works with solving the problem of circular dependency. In the first example, first step of this refactoring process, we had the circular dependency between two libraries. Maybe you will decide to split those objects to two libraries. And on the left, you see that our customer class was relay on the product, and our product was relaying on the customer. So we had a circular. But after we introduced this interface buyer, now all the shape, all the contract that has to be fulfilled by other objects is inside this product library, which is really nice because having the code like this gives you the possibility to test it without the real implementation of the buyer interface. You can just easily mock this implementation in your unit tests and check if everything works, and then ask maybe another team to create the customer byproduct implementation and just use it in our application. So we see that this coupling was removed, and now only customer relay on the product. And we have the one-way coupling. And that was the dependency inversion. I didn't want to tell you the real description of this rule because it's so complicated that it was much easier to explain on the examples instead of just reading it from the Wikipedia or something. But how we can decouple the data structure? And this is really important because maybe in your project you want to work in parallel on single story or a task. And for example, one of your colleagues will prepare the contract with the backend. Another one will work with the routing and create the libraries as a base. And another one will work on the UI. And as I've seen in many projects, that there are some people that are very good at UI, and some of them are better on the application level, not the UI level. So the task should be split on those persons, and the one who do the job the best of its own can do his own part. Imagine that in some projects, the get product response is passed to the UI component, and every time we want to change the contract with the backend, we need to update our UI elements, which is really, really painful for our application. And as well, if you want to start your task doing the UI elements, you need to wait until your colleagues will talk with the backend about the contracts. They will create the object for you, and then you can start. And this contract may change. And what if you want to use the storybook and show your components on the storybook? It's not that easy to provide all the response objects. Maybe there will be some differences. Maybe the UI component will not use all the elements from this product response. Should we mock them in the storybook? It's really annoying. So you can decouple those data structure by just mapping the response to the UI interface. So for example, this component, this card UI, can have the interface. Of course, the dependency inversion principle will tell you that the get product response should implement the card UI. But in the Angular, it will not be a good idea because then you will have a coupling between the card UI and the get product response, or on the other way, which is not so good. So I recommend to have a mapping. And as you see in this case, for example, we have two responses. One is for getting the customer service, for example, like extended warranty for the product. and second one gets the just the products. So you can easily combine them by having one list on your front-end application, by mapping the customer service response and the product response to the same interface, which is card UI. And as you see, this card UI doesn't have any dependencies on other objects. So in this example, you see that this card UI can be used almost for everything. And it's really hard to guess how your application will look like. Will this component be used only in one place or in multiple places? So I would recommend to use this separation in your application. Another thing is interface segregation. And I've seen that many times in the front-end application, people use the very big objects. For example, the product can have like 20, 30, 40 properties, which maybe for some applications is good, but maybe sometimes this interface has like half of the nullable properties or optional properties. So maybe it's better to create two interfaces. And as you see in this example, for example, we want to calculate the sell price. And when we pass the whole product, we see the logic of this is pretty similar as the same one on the bottom, when you can calculate sell price, but only using separate interface or the partial object, which only includes the net value and value-added tax. But where you will see the difference is your tests, because wherever you want to test this function, you will actually need the product, the whole product interface, which gives you unnecessary coupling to the product interface, and wherever something is changed in this product, you will need to update your calculate sell price function. And you can see here two examples of the tests. And in the first example on the left, we need to create the whole big object of the product, which has properties like description, SKU, name, which are not needed to calculate the sell price. And the amount of the code duplication in your test will be very huge. And wherever you want to change, for example, remove property like description, we say we don't need description anymore, then you need to change your tests. And that's the bad behavior we don't want, because either you want to refactor your tests or your code. You should not do those things together when you have the good architecture in your system. Only you need to update your tests wherever your behavior of the application changes. But yeah, like removing the property here will not change the behavior of the calculate sell price. So your code should affect only the places where this description is used. So on the right, you see that the test was very much simplified, and it's much easier to test, and we don't have like this overhead dependency on a product. And why we do it? So as I said, to work in parallel on single task or the story. So you can deliver your code faster. You can create smaller pull requests that are easier to understand. You can understand your project better, because maybe you'll have a chat with your colleague that do the same story with you. For example, he's doing the UI part, you are doing the data part, and then you can more easily check your pull requests and know the behavior of the system better. Another thing is to reduce the bus factor, so we can much more easily switch the tasks. We don't need to make the whole story. The whole story don't need to be made by one person. So the bus factor, if someone don't know it, is the factor what will happen if some of your team members will be hit by the bus and he will not come to work tomorrow. So will your project be able to run, or it will stop because the bus factor was so high that no one can take over the tasks of that person that is not able to work with you anymore. And of course, at the end, we do it to deliver things faster. And that's it. You can check the extended example of this, what I shown you here, with some more details, like added value objects, making sure that all the objects created are created correctly. And you can use this QR code or this URL to check it by yourself. And at the end, I will just show you how to use the repository. This is the NX-based repository, so you can just start an app. It's very simple. Let's wait until it will load. So the app looks like this. It's very easy. You can see the example with the UI part here, but also you can see all the examples I shown you in the exercises library. And here you have all the steps that I was doing to refactor this application. And as I said, this is followed by the tests. And you can run those tests to each step. So for example, we want to run these tests for step 1. Yeah, and we see that everything works. But you can easily switch the import here and run this test for the step 2. Very simple. You can mess around with the code. You can play around with it. Maybe you want to add something like handling the bank account for the shop, or adding the coupon codes or things like that to just train your skills in object-oriented programming. And that's it. Thank you for your patience. Questions? Okay.
In your opinion, what should be more stable, UI or the business logic? I mean, what should import what? As domain or business logic should know anything about UI components and UI interfaces, or the opposite?
It depends, because sometimes.
The question?
Yes. So what is more important, having the constant business logic, right, or the UI components? And should the business logic be adjusted to the UI components, or the opposite, right? So it depends how you work in your project, because sometimes you have like the way of working that is upstream, downstream. So for example, you cannot change the API because the API is from like external provider. You will not, you're not even able to ask them to change anything. For example, they deliver their solution to multiple clients. So then you need to adjust your UI, your front-end layer, to be able to work with this API. But sometimes, yes, you can tell your backend team to change things. So there is no single rule. I think the UI components should be very flexible, so that we can adjust as many requests as we can to reuse the UI components. And by having this separation between the contracts and the UI interfaces, you're allowed to do that.
Okay. What do you think about making UI components not flexible, but create some kind of adapter pattern inside the application to adopt data from backend to your UI and don't change UI instead? Like make UI stay the more as possible, but create some kind of adapter with converter inside and convert all data from backend to frontend. Doesn't matter what you get.
Okay, so you mean like very universal. I will just repeat the question.
Yeah.
Well, I hope I will be able to repeat it. So what I think about having the very universal components that backend can adjust, like in the middleware, in some kind of middleware, like in the adapters.
Backend or frontend, you create some kind of layer between them, like facade or something like
Yeah.
adapter. And inside this adapter, you can implement some kind of converter to convert data from backend model to frontend model. Don't change like backend or frontend. Just change this converter inside.
Yes. So I was talking about that, and this converter will be mapper. I thought you're talking about something like backend can change some properties to adjust the look and feel of the UI components. I'm not sure if I get it right. So yeah, I think I would not rely on a backend so much when it comes to adjusting the UI components, because the backend should not know about the UI components, because then probably the backend endpoints will need to know about every UI element on the front end, which will be very messy because the backend guys will not understand all the UI logic. And the reason that we want to split our code is that we can choose like one team that's doing their job in the best way possible, and they don't need to know about other parts of the system. So for example, on the backend, we sometimes use the context, and we map the context just to find the different teams that can handle different logic of the application. For example, like they can have similar models on the backend. For example, we can have sales context, and then they can have the product with some product properties. We can have another context for the stock, which will also represent the product, right? But the properties in the stock context will be much different because, for example, for the product context, SKU will be the primary identifier because they need to know what they sell. The SKU represents the product, the package of this product. So for example, two packages of the same product will have different SKUs. But for example, on the stock, the primary identifier that we'll be interested in is, for example, the place where this product stays, and they will never use the product term for that. They will just tell it, okay, I need to go and take the stock item and bring it to you because you need it. For example, for shipping, that's how they work. They split the context. So here you can also think about this as splitting the context. So we have the backend context, and the backend context should not know anything about the frontend. Of course, sometimes the frontend guys will ask, can you do it in two separate requests, for example? We don't want to wait that long until this data is loaded, right? And they can split it for you.
One more question.
Okay.
Object-oriented or functional? Because you have presented two samples of the same logic,
Yeah.
product and consumer. So what approach do you find more usable in Angular and front-end heavy way?
Yeah, it depends for what we use it, because in the functional, it's not that easy to use this abstraction, right? It's much easier to use abstraction in the object-oriented programming, in my opinion. But on the front end, I would say there is not much business logic. It's like presenting the data mostly, unless you have the PWA application and you need to duplicate the logic from the backend on the front end. So then I would recommend to use the pure object-oriented programming, use the context of your application, and then split those objects to the smaller parts and keep this behavior inside the right objects. We don't want to have situation where one library or one object will grow and grow and grow every time you add something. Yeah. If you have something like this in your application, then you will see it very fast in the NX affected if you use NX, for example, and it shows you the affected libraries, and this can cause that your CI can run like 30, 40 minutes because your CI needs to check all the application, and you need, if you split the libraries to the small parts, you have the right abstraction, you're able to run your CI like in 5 or 6 minutes in your PR, which is really, really nice. And scalable. Any more questions? If no, then thank you. You can reach me, of course, in the hall. So thank you very much.